Okay, so there are two parts to this problem. One is they're wanting you to write the formula of the conjugate acid when they give you the conjugate base, and the conjugate base when they give you the conjugate acid. And the second is just a plug and chug problem. So let's start off with the very, very straightforward thing. And all you have to remember is that the difference between a conjugate acid and a conjugate base is just an H plus. So if we look over here, we have a ClO3 or ClO minus. So all we have to do is add an H in front of that. And what we're going to end up with then is HClO. Now over here, we have CH3 NH2, and again, all we have to do is add an H plus to it, and that's going to give us CH3 NH3, not 2, but because we added an extra H plus, it's now a plus. And then conversely, right over here, we have NH4 plus, and they love giving you ones that look like this, because then when you flip it over, you're just subtracting an H from it to get to the conjugate, and that's going to be NH3. And they also, College Board in particular, likes using the NH3 because if you're a little bit naive, you're going to look at this and go, oh yeah, there are a bunch of hydrogens right here, that must be an acid. In reality, this is the conjugate base of this. So we've taken care of the conjugate acid base portion. Now the plug and chug portion, and it's simply this. All you need to know is that Kw is equal to Ka times Kb. Now, Kw is 1.0 times 10 to the negative 14. This is one of the ones that you need to have in your repertoire, Ka times Kb. So if we know this equation right here, and we know either our Ka or our Kb, that's 2 out of 3 variables that we can solve for our Ka, or the other way around, if they give us the Ka and this, we can solve for this. So in the first problems, if you take a look, they're asking to solve for the Ka. So all we're going to do is rearrange this equation right here to isolate Ka. So for the first row right here, we're just going to go Kw divided by Kb equals Ka. And we're going to do the same thing for the second row. But when we plug our numbers in, we're going to put on the top 1.0 times 10 to the negative 14, all over 3.3 times 10 to the negative 7. And that's going to equal 3.1 times 10 to the negative 8. We're going to keep the same significant figures that they had before. Then for the second row, also another Kw divided by Kb. We're going to make that equal to our Ka. And again, we're going to go 1.0 times 10 to the negative 14. But in this case right now, we have 4.4 times 10 to the negative 4. And so you can see that these are just literally plug and chug. Plug the numbers into our equation and then chug it out on our calculators. Times 10 to the negative 4 equals, and from having done this already off screen, that's 2.3 times 10 to the negative 11, and that's going to go in this spot right here. And then finally for our third, they're like, whoa, let's see if you can figure this one out. And in this case, they're asking us to solve for Kb. And again, if they're asking us to solve for Kb, wouldn't that be Kw divided by Ka? So we're just going to write that down here just so you have a frame of reference. The only thing we're really doing is substituting in the Kb with a Ka, and that's going to be equal to my Kb, and the same math follows. 1.0 times 10 to the negative 14. All that's going to be over this number right here, 5.6 times 10 to the negative 10. And when we do the math on that, we're going to end up with 1.8 times 10 to the negative 5. Now, in reality, and you can take these and move them however you can't obviously do that, but that would go right here, this would go right here, and this would go right here. Hopefully this has been helpful to you. Have a great day.